you increase the flow in a system, and suddenly the pressure reading drops. Immediately, everyone thinks something is wrong. The pump must be failing, there could be leakage somewhere, or maybe the pressure sensor is faulty. But here's the unfiltered truth. Pressure didn't disappear, it changed form. To understand this, we need to stop treating pressure as a single thing. Pressure is simply energy per unit volume. And in a flowing system, energy can exist in different forms. Two important ones are static pressure and velocity pressure. Static pressure is what pushes on pipe walls. Velocity pressure is the energy associated with motion. When flow increases, velocity increases. That extra velocity energy has to come from somewhere. So part of the energy shifts away from static pressure and into velocity. Nothing has failed. Nothing has leaked. Energy has simply redistributed. Now here's where confusion starts. Pressure gauges only measure static pressure. They do not measure velocity energy. So when velocity increases, the gauge shows a lower pressure reading. To the instrument, it looks like pressure dropped. But in reality, total energy in the system may be similar, just rearranged. On top of that, higher flow brings higher losses. Friction losses increase rapidly with velocity. Valves, bends, fittings, and pipe roughness all add resistance. So at higher flow, more energy is consumed overcoming losses. This further reduces the static pressure available at the gauge location. That's why, with the same pump, you can see higher flow and lower pressure at the gauge at the same time. Nothing broke, the pump didn't weaken. Physics did exactly what it should. So why does this confuse engineers? Because we often measure the wrong thing. Pressure alone doesn't describe what's happening in a flowing system. Flow rate, velocity, losses, and gauge location all matter. Here's the key takeaway. Flow increasing while pressure reading drops can be completely normal. You must look at the full system, not just one gauge. Pressure didn't drop. You measured it wrong. Subscribe to Engineering Unfiltered. For real engineering, no filters.